Welcome to Excel Magic Trick number 1071. Hey, if you want to download this workbook file and follow along, click on the link below the video. Hey, in this video we have a great example. We need to look up product 2 and get all the values from February to April. So right now we need to look these values up and add them. If I change this to product 3, boom, I need a different set of numbers. If I change April to August, boom, I need a completely different set of numbers. Control Z, Z. So how could we solve this? There's actually a bunch of ways we could solve this. I'm going to look at a bunch of cool tricks. The first couple examples, we're going to create dynamic ranges using offset and index, which are probably the best way to solve this. Then the third example, we're going to see what in the world you do if you had the column numbers you needed in a cell like this. And then we have a few extra wild examples here. Now, actually, I have some notes over here about the concepts that we will see in these examples here and the page numbers in the Ctrl Shift Enter book that I wrote. That's a book about advanced formulas and array formulas. By the way, it's not just about array formulas. There's lots of cool advanced stuff in there like offset and index. I'm going to move that over because these formulas are going to get pretty big. All right, we're going to start with offset in this cell to create this dynamic range. Now, here's how offset works. Offset, we're going to tell offset to start at cell A14, go down 2 rows, then over 2 columns. And then we'll say, hey, offset, the size of this range is 1 row by 3 columns. All right, we're going to start up here. Equals offset. All right, so the reference is the starting position. So I'm going to click on cell A14, comma, rows, we're going to use match to look up product 2, comma, within this range of values. Match finds the relative position, so 1, 2, it will report 2 to offset. That's how many rows we need to go down. Comma, we're using a 0 here. These are sorted right now, but product names might not. So I'm putting exact match lookup. Comma. Now columns. So far we've started here and gone 2, but we need to move over 2. So for columns, we're simply going to look up using match February, comma, within this lookup array. Right now, it will say, where's February? The second position, comma. Those are not sorted, so we have to say exact match. All right, so now we're starting here, going down 2 rows, over 2 columns. Boom, that's the starting position. Now offset knows where to start, comma, how high, or what's the height of this range. Hey, the reference is a 1 by 1, meaning a single cell. So if we leave this argument empty, it assumes the height of the original reference, which is 1. So that's good for us. Comma, the width, we need 1, 2, 3. So watch this. We're going to say we're actually going to have to use 2 match functions. We're first going to look up April and subtract February to get 3. But watch how we look up April. Lookup value, I'm looking up April, comma, the lookup array, if I highlight this, it would be 1, 2, 3, 4. And I want 5 minus 3, so I'm going to highlight 1 cell before. We could add 1, but because we have, as part of our lookup table, that first column, it's perfect, comma, 0, because it's not sorted. All right, that'll give me 5. And we can prove this to ourselves by clicking and hitting F9. That's going to give us 5. Control Z after you hit F9. But we want to subtract. We've already typed that out. Control C and Control V. That will give us a 2. Click on the width, F9. There's our 3. And that's dynamic. No matter what 2 months we put in here, it'll always give us the right width. Control Z. Close parentheses on offset. Offset has all 5 arguments entered. I highlight an F9, and no way. Look at that. It got the values. Now check this out. If you watch these videos, you know this is array syntax. Array formulas spit out an array of values. But offset and index spit out something. Yes, it's an array of values, but it's a range that other functions can understand without Control Shift Enter. So when we use offset, if there are no array operations in our offset, causing us to do Ctrl Shift Enter. We don't have to put it in SUMPRODUCT. We just put it in Sum and hit Enter. Absolutely beautiful. And we can test this, right? And there, it jumped down here. I'm going to highlight this and watch this. I'm going to look at the status bar. It says Sum 484. It got it right. Control Z. Now, offset, that's pretty groovy. Offset is a volatile function, which means if you do anything like type something and hit Enter, insert a column, it will recalculate. The vast majority of the time, that's perfectly OK. But sometimes if you have large spreadsheets, that might slow down calculations. So we can create dynamic ranges using the index function, and index is not going to be volatile. Now, index will create the same range, but in a totally different way. Here's what we're going to have to do. Index will actually look up the cell reference C16, the first one, and then it will look up the second one, E16, and from those two cell references, create a range of values. All right, so index is a great lookup function where you can do two-way lookup. Here's all the values. Now notice it's got coordinates for the starting position. The row is 1, 2, and the column is 1, 2. So 2, 2. We put in our whole two-way array into the array argument, comma. Now I need a row number. Well, I'm going to use match to look up product, just as we did earlier. That will report a 2 into the row number, comma, and then the coordinates for column, match. And we're looking up February, comma, within, comma, 0, close parentheses. That will return, well, watch this. Index, if we highlight it and hit F9, it does not return a cell reference. It returns the content of the cell 135. Control Z. That is how index is programmed to work. However, if you put index into the context of a cell reference or a range of values, it will look up the cell references. So watch this, colon, right? Cell ranges go from one cell colon to another cell. So I got that colon there. I'm going to copy this because if we're looking up the second cell reference, this works exactly the same except for one difference. Oops, I forgot the parentheses on the end. The only difference is we're not looking up February. We're going to look up April. See, April will return 1, 2, 3, 4. So the coordinates are 2, 4. Now, if you highlight the index again alone, F9, it returns the value, Control Z. But if you highlight everything, including that magic little colon, then F9, it's returning a range of values. Now, it's actually looking up the first and second cell reference and then everything in between. If you're in edit mode and you hit F9, you can't see the cell references, but index really did look up those cell references. In fact, we will look at an example of how to see that in just a moment. Index, just like offset, it's spitting out a range of values. We don't need to use SUMPRODUCT. We just throw it into Sum and Enter. Now, let's run Formula Evaluator. Formula Evaluator is right there. Or we can use the keyboard Alt-MV. And watch this. If we click Evaluate or hit Enter, just watch this beautiful evaluation. Enter, enter, enter. Watch, index is about to get calculated. Boom, it got C16. And then enter, enter, enter. Boom, I got C16 and E16. So it's actually looking up cell references. Absolutely beautiful. Now, our next example, what if we were not given February and April? And I kind of like this because it's explicit. It's visual from February to April. But what if you were confined and your solution had to have column numbers in the cells? Then the formula would be totally different. But guess what? I'm going to use this one. I could use either one of these. I'm going to use offset and then change some of the inputs here. I copied it in edit mode. Now I'm going to put it Control V here in edit mode. And now where is the information coming for this formula? It's not coming from the relative position of February or April. It's coming from 3 and 11. Oh, wait a second. It's supposed to be 3, 4, 5, not 11. All right, so the information's coming from a text string. This is text. We need to get the first number, which is column 3, and the last number, which is column 5. So check this out. Getting the first one's relatively straightforward. Hey, we're just going to say, hey, please give me the left, comma, how many characters? Well, I can't just put 1 because sometimes that might be 10, right? So I'm going to search for a comma. That comma is in double quotes within here. And search will tell me the position of that comma, which is 2, and we always need to subtract 1 from it. And that'll always get me the leftmost number, even if it turns out that this is 11 or 10 or something. Control Z. Now getting the last one. Well, if we use the left, let's use the right. Now the right of this text string, comma. The problem here is just like with the left. Sometimes it'll be a single character, and sometimes it'll be 2. So, and I don't want to try and search for the last comma because that little formula element can get complicated. So I'm going to give the number of characters to extract from the right argument an array constant, 1, comma 2, because the biggest it could ever be is 2 for 12. Right? Well, this is a function argument array operation. So when I give this argument 2 values, right will spit out 2 values, F9 to evaluate it. Notice it's a comma and a 5 and a text 5. Control Z. Now watch this. If I just enter this and come up here and put an 11 here to check it out. Now we're going to get F9 2 numbers, right, as text. Let's put this back to 5. And what we're going to do here is, first off, we're going to add 0 because I want to convert those to numbers. And when there's a single number, F9, when there's a single number, we're going to get a value error. If that's a double-digit number, then the big number we want is at the end. But notice it's always going to be the last number in this little mini array, Control Z. So I'm going to use the lookup function, lookup, which only does approximate match, not exact match. And if you give the lookup value an approximate match that is bigger than anything in the array, it'll always get the last one. The biggest number it could ever be here is 12 because of our 12 months. So I'm going to use a 13. You can put whatever big number you want there. And that will always look up the last number, even if it is 11. Control Z. Now I actually learned this trick with right from Xlarium at YouTube, and I actually have a note over here. And this is the formula I learned from them. This is a little bit more robust because it'll find the last number in any text string. That's a pretty cool trick here. Now we have our bits of information, starting column, ending column. We can amend this formula. Now I'm actually going to copy both of these formula elements, Control C, C to open up my clipboard. Clipboard is up there if you don't have CC keyboard turned on. Here's the last little bit for the 5. Copy, escape. Now I'm going to come here. All right, so we used offset. And the row number is fine because we used product and jumped down to. It's the columns, right? That's given us a 2, and we really want to use this left. That gives me 3, so I have to subtract 1. Now, if I click on the columns and hit F9, boom, now it's got that 2, which is how far from this position do you want to jump over, Control Z. Finally, the width, we use 2 bits of information. Here we need the 5 from our last lookup there, getting the last value there, and we subtract our left. Now that's given us 3. We have to add 1 because we really want to subtract 2, so we have to add 1 back in. And boom, if I highlight that and F9, there's our 3 for width. The information in this formula for the columns is coming from that text string in the cell. That is a wild formula. Now, those ones, probably the first 2 are the best. That one, if you were constrained by this requirement here. Now, another example we could use is we can actually use VLOOKUP to do this. But here's the deal. What if you were always looking up the same 3 columns, 3, 4, 5? We could use VLOOKUP, and we wouldn't need to worry about a dynamic range. I'm going to look up this product within this table right here. comma, and this argument's expecting a single column number. I'm going to give it 3 columns. This will be a function argument array operation. So in array syntax, curly bracket 3, comma 4, comma 5, in curly bracket, comma 0, because these are not necessarily sorted. Now VLOOKUP, we give it 3 values here, so that instructs VLOOKUP to spit out, boom, 3 values. There's our 3 values. Now we can put this inside of SUMPRODUCT to add. Now most of the time, as I mentioned in my book about array constants and formulas like small and large and many other OR and other functions, if you use an array constant to do a function argument array operation, you don't have to use Ctrl Shift Enter. But VLOOKUP is one of those weird ones, this column index number, that doesn't abide by that. Now the strange thing about array formulas, of course, is there's no guide. Microsoft doesn't put out rules about how all this works. So it's just kind of hit and miss when it comes to that. But VLOOKUP, we got to put in SUMPRODUCT. SUMPRODUCT, however, that argument can handle this array of values created by VLOOKUP, no problem. Enter, and it adds them right up. Now, if you wanted to have this dynamic, depending on what you put here and here, I'd use one of these formulas up here. But if you wanted to go crazy, you could create from these 2 inputs a variable length array of sequential numbers. Now, the information about where to start and end comes from match. So I'm going to take match, and I'm going to look through product and all of the months, comma 0. And I need some sort of range of values. So I'm going to join a colon in double quotes to a match that looks up April, comma, within this whole range here, comma 0. Now, if I highlight this and hit F9, it creates, 3 to 5. Now, notice it's text, but that actually is a row reference. It means go all the way from row 3 to row 5 as text. Well, we need to convert it back to a reference. So INDIRECT function does exactly that. Text that's a reference converts it back to a reference. If I highlight this and hit F9, it will not work. It says way too many characters, because from row 3 to 5, that's a lot of cell references. So we can't see it there. You actually can see it in Formula Evaluator, but it just is huge. That's 16,000 times 3 or something. But if we put it inside of row, row will look at that row reference and just spit out the array F9, 3 to 5. Control Z. Notice those are semicolons. That means rows. Control Z. Now I could copy this as a formula element. Oops, I'm going to put this back here just to leave it there. And come and highlight this little bit. Ready? Control V. Now this, it looks like I missed that last curly bracket. I better delete. If I hit Enter, not going to work. Remember, VLOOKUP is one of these functions that just doesn't work like a lot of other functions. This column index number, even though we had an array constant and SUMPRODUCT was handling it, now SUMPRODUCT can't handle it. So in this case, since we want to be unambiguous, I'm putting in sum because this formula requires Control Shift and Enter. Oh, that is better to do one of these up here. Now, there's a few other ways we could do this, or other situations we might be in. Here's that same formula I just did, and there's our row, etc., to create that dynamic array of sequential numbers. But I put it inside of index because index array argument can handle array calculations without using Control Shift Enter. The trick is that the row number argument right there has to be empty or 0, and then index will return all the values. And then boom, we can use it in SUMPRODUCT without Control Shift Enter. That's ridiculous. All right, here's another ridiculous one. If the information came like this, and this formula is ridiculous because we'd be limited to 3 months, right? Which might be fine. Then we could do the SUMIFS array operation to go and look up 3 values. Now, what this formula does in the sum range is index is looking up the whole row. So match is looking up that product, and this index here, because, again, column number is empty, it says give me all the columns. So we have the row number, all the columns. F9, that looks up an entire row, right? Control Z. Well, that's sitting in some range. That's like a row of values, Control Z. So now the criteria range is the months, and we do a function argument array operation and criteria looking up February, March, and April. We're looking up February, March, and April. That's 3 values, so that instructs SUMIF to return 3 values, which is exactly a 1, 2, 3. Or in this case, February, March, April, which would be, oh yeah, that's right, F9, and there they are. Still, another way we could do this, and this actually has an interesting thing that I never learned before doing this formula. Address is a function that allows you to create a cell reference. So what you do is you give it, hey, a row number and a column number, and it creates the cell reference as text. But watch this. Match is looking up product 4. So if I hit F9, that's a single number. It's the row number 18. Right there, 18, Control Z. You can notice I highlighted this whole range here from A all the way down to there. But watch it, that's a single number. But column, that's a function argument array operation because I'm giving match 3 values. So if I come here and highlight that, boom, it's 3 values. So address has a single row number, which is 18, and 3 of these. So it's going to have row 18 with column 3, 4, and 5. And address will know how to deal with that. Watch this. If I evaluate F9, it returns the cell references, the exact cell references here. Control Z. Indirect to convert them back to cell references. And then N to dereference them and allow them to go into SUMPRODUCT to add. Wow, that was an epic video. Lots of maybe potentially useless stuff for this particular solution, but interesting stuff in and of itself. There's some notes over there. All right, we'll see you next trick.